Hi everyone, welcome to this lecture on hydrogen fuel cells for AP Environmental Science. We're looking at topic 6.11, hydrogen fuel cells. The learning objective is just describe the use of hydrogen fuel cells and how they generate power and or electricity, and describe the effects of hydrogen fuel cells on the environment. So you may have heard of hydrogen fuel cells in the past, but you may not have a clear understanding of what they are or how they work, and that's okay because we'll talk about that on the next slide. But hydrogen fuel cells, or HFCs, are kind of like a battery, except a battery is all self-contained. All the materials in that battery are inside of that battery, and they're going to use metals like lead or lithium inside that battery. However, a hydrogen fuel cell is going to use hydrogen and oxygen. Those two are going to react together to produce water. So water is going to be our waste product. The hydrogen is going to be in continuous supply from a tank. So I'm guessing that one of these clear tubes in this top right stack of hydrogen fuel cells is going to be hydrogen coming from a tank into the fuel cell. Oxygen can be coming from the air, but it can also be coming from a tank as well. And you're going to need some metal catalysts and some electrolytes and everything, electrolytes in there to facilitate the reactions. The first hydrogen fuel cell was invented in 1838, so it is a pretty old technology, but it really hasn't gained much traction. The first commercial use of them was about 100 years later. And the most widespread use, or the use that most people think about, is in the space program. So if you see in Apollo 13, they talk about the hydrogen fuel cells in that movie. So NASA is one of the bigger users of hydrogen fuel cells, especially in the space programs in the 60s. So yeah. So how does a hydrogen fuel cell work? Well, there's a lot of varieties in hydrogen fuel cells, but they differ primarily in the materials that they use for the anodes and cathodes, the electrolytes, the catalysts, all of that stuff. So we're not really going to worry about the differences. We're just going to look at the basic general format of a hydrogen fuel cell, and that's modeled here on the right. Essentially what you have is hydrogen gas reacting with oxygen gas to create water, liquid water, which is your waste product. However, it's never that simple, so you have to go through all of the steps. The steps, you're going to have the fuel that goes in, so that's going to be your hydrogen gas that goes in. That hydrogen gas is going to react with a catalyst that's going to split that hydrogen gas into two hydrogen molecules. And then those electrons are going to be stripped off of those protons. So remember that an H plus is just a proton, and the electrons are going to be removed from it. These protons can flow through this electrolyte. They can just diffuse right through this electrolyte, no problem. However, the electrons can't. This electrolyte acts as a barrier to those electrons, and they cannot pass through. So instead, they're going to be provided a wire in order to get over to this cathode side. That wire is going to allow those electrons to flow, and flowing electrons is all that electricity is. So as these electrons go through this wire, you can harness them as electricity. So you can have them going through all of your machinery, get sent to the grid, get sent to a motor or whatever it is, power a light bulb. It doesn't matter. Flowing electrons are your electric current, and they can go through any route, through any types of appliances, and then eventually be returned to the cathode side, where they're going to recombine with the hydrogen gas. They're going to react with the hydrogen ions, the protons. They're going to react with water using a catalyst, and I said react with water, but react with oxygen using a catalyst, and they're going to create water as your waste product. So oxygen is going in on this cathode side, reacting with the hydrogen in the presence of a catalyst to create water, and that water is going to leave as a waste product. Okay. So we can use hydrogen fuel cells to really power anything that requires electricity. You guys don't need to know DC versus AC. It's not really important for this class, so don't really worry about that. I know it's on the last slide. I know it's here, but don't worry about it. But one thing that I do want to say is that each fuel cell is going to produce only a little electricity. There's not a lot of electricity that each fuel cell creates, so they're going to be stacked together. They're going to be stacked in series so that they produce more electricity together rather than a little bit individually. So depending on how many we stack, depending on how many we need, we can power anything from a couple light bulbs in a house to a laptop to an industrial sized power plant. It really just depends on the scale that you want to go, how many of these fuel cells you need. The efficiency can be pretty high, so depending on the type, you can get anywhere from 40 to 70%, or as high as 85% if cogeneration is involved. I define cogeneration here, but we're going to talk about cogeneration on another day, so I'm going to skip it. But I do want to say that these fuel cells do produce a little bit of heat, so this exhaust gas and the heat can be used for cogeneration, and that will increase your efficiency. So let's talk about whether it's renewable or not. Now, hydrogen has to come from somewhere. Hydrogen is a natural gas, but it is like it's a naturally occurring gas in the atmosphere, but it is a very, 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 very small trace portion of the atmosphere, and it mostly exists in the upper atmosphere rather than down here in the troposphere. So we have to get this hydrogen from another source, and essentially what we're going to be looking for is anything that has a lot of hydrogens on it, right? Any molecule that has lots of hydrogens. So it could be methane that we're getting our hydrogens from, right? We get a carbon with 4 hydrogens on it. But the problem with any of these hydrocarbons is that they are not renewable, right? You have to mine them, you have to get them out of the ground, and then that carbon something has to happen with that carbon. Worst case scenario is that when you refine hydrogen from methane, you can release carbon dioxide. That carbon reacts with oxygen to create carbon dioxide. You know, you can sequester that carbon in other forms, but usually the waste product is going to be carbon dioxide. So that's not going to be renewable. Okay, just by definition, the fact that you're getting it from fossil fuels. You could be getting it from biomass. So you could be going through a gasification process. You could be going through a fermentation process to produce methane from biomass and then and then refine that methane to hydrogen and capture the carbon. That would be more renewable, but they have to be managed properly. Or you could be doing water electrolysis, which is essentially splitting a water molecule into its component parts, hydrogen gas and oxygen. That can be renewable, but it does require electricity. All of these do require energy in. So splitting hydrogen off of anything, refining hydrogen off of anything is going to require an energy source. Now, is that coming from fossil fuels or is that coming from renewable? Okay, so it really just depends on where all of the stuff that you're getting the hydrogen is coming from. Okay, now an example of a fully renewable one, you could do water hydrolysis. So let's say that you're next to the ocean and you have a ready supply of water, or maybe you want fresh water. So you are next to a really large lake, for example, or a large river. You can take off a little bit of that water, be renewable, and you could do water hydrolysis with solar energy to supply hydrogen for hydrogen fuel cells, and then it's going to create water, excess water, that you can release back into that natural waterway. Okay. One of the cool things about hydrogen fuel cells is that they do provide a consistent energy supply. So you can use them in conjunction with various renewables. So for example, you can use solar during the day and then store the excess solar energy as hydrogen by doing water hydrolysis, and then use the hydrogen fuel cells at night. So it picks up some of the slack of that variable solar energy. Now, you do need a lot of other materials in order to make a hydrogen fuel cell, right? You need all of the metals to create the wiring, the electrolytes, the catalysts. That can range from any of these metals here, including some things that are not metals, such as sulfuric acid and phosphoric acid. But you know, platinum, for example, is pretty rare on the surface of the planet. So all of these have to be mined, except for the 2 acids. And mining is going to come with its own environmental costs. You also have plastics that make these fuel cell frames. So it's not, you know, a total panacea. So hydrogen fuel cells don't represent a large part of the global market, less than a quarter of 1% of global energy use. That's only $6.4 billion in 2018. But optimistic expectations suggest that it can grow up to 20% in the next 10 years. One of the problems with that, though, is they've been saying that for the past 30 years. Hydrogen fuel cells have always been one of those things that just have not been economically viable yet, but in 5 years it will be. And every 5 years they keep saying that, right? 30 years ago they said it'd be economically viable in 5 years, and that was 30 years ago. But it is still heavily researched and people are trying to make it economically viable. It's one of those energy resources that once it is economically viable, there's so many benefits of it, especially the fact that it is really clean and it produces no greenhouse gases whatsoever, at least during use, um, that it has huge capacity for growth. Hydrogen fuel cells vehicles are also continuing to be researched. There's still prototypes all the time being built and tested, but there is some problems with that. One is that if you have a tank of hydrogen in the back of your car, if there's a crash, explosions are a huge concern. Just think of the Hindenburg, for example. Um, that's on a much larger scale than a vehicle, but still, same thing applies, and you do not want to be on that car when it blows up. And there's minimal distribution of hydrogen fuel cell infrastructure. But once hydrogen fuel cells become economically viable, they are going to take off, no doubt about it. So let's summarize the pros and cons of hydrogen fuel cells. There is near zero emissions once operating, so that doesn't include the mining of the materials, that doesn't include where you get the hydrogen from, but when it's operating, there is no carbon dioxide, no carbon monoxide, no nitrous oxides, no sulfur dioxide, no gaseous waste except for steam. And then the only waste product is water, whether that's liquid water or gaseous water. There's no or very little water pollution because it's pure water that comes out of this, depending on the efficiency of the fuel cell and the type of fuel cell that it is. But there's, let's just say, no water pollution. There's no net reduction of water on the planet. So even if you're doing water hydrolysis, you take a molecule of water, split it into hydrogen and oxygen, then you put hydrogen and oxygen into the fuel cell, you get that same molecule of water back. So there's no net reduction of water on the planet. Um, it's basically silent. It's a consistent energy production. It can be very efficient, and there's little to no human health impacts. So it is really, really, um, you know, really, really desirable, really, really marketable once it becomes economically viable. Once you get more electricity out of it than you put into it to refine the hydrogen. Some of the drawbacks, though, there is material use, right? You do have to mine the platinum or the cobalt or the cesium or whatever it is for the catalysts and the electrolytes and the anodes and cathodes. You do need to, most of them require plastic to create the shell of the fuel cell. You have to generate the hydrogen. This is the big part. This is the big thing that is holding the entire technology back because right now it takes more energy to split a water molecule or to harness this hydrogen from methane or whatever source it is, then it takes more money, more energy than you get back out of it. But once it becomes cost effective, it will grow. You do need to stack these cells. Okay, they do need you do need a lot of them to meet power demands because each individual one doesn't create a lot of power by itself, but you can stack them however big to create a lot of power. One of the other really, really problematic things about it is that storing hydrogen is very dangerous because it is a highly flammable gas. But welders do it, so why can't other like electric companies? So let's talk about some success stories with hydrogen fuel cells, some places that they have been used and used successfully. So there is a couple slides ago, you guys actually saw this in one of the corners. The Anchorage Mail Processing Center provides 1,000 kilowatts of electricity and the waste heat used to heat the building, and they've been doing that for quite a few years at this point. So they power that processing center with these hydrogen fuel cells. There's a jail in California that has its own little power plant. Most jails do so that they're not reliant on the grid. So if there's a blackout, the prison doors don't open by themselves or something. But anyway, this power plant installed hydrogen fuel cells and they provide what is 8 8 million kilowatts of electricity, which is half of the jail's needs, and produce 18% of the heating needs of the building through cogeneration, and they have a 98.5 reduction in nitrous oxides compared with the standard power plant that they had beforehand. That is a huge reduction in nitrous oxides, which is a smog-creating chemical, and we're in California, Alameda County, near, you know, in this example. And then also in California, there is a FedEx hub that installed hydrogen fuel cells for 500 kilowatts of electricity. They use solar panels as well, and they have a continuous supply of power for that site. So there are people that are working on hydrogen fuel cells all the time, and they are hopefully going to be a growing part of the economy in the coming years because they do have lots of benefits. All right, you guys can read through the essential knowledge. You read through the learning objectives. I'm going to end it here, and I'll see you all in class.